So warm greeting to all. This session we are going to discuss design of flywheel using PSG data book. So how to design a flywheel using PSG data book. So here energy stored in a flywheel. So this is a flywheel diagram. So here this is arm, this is hub, and this is rim. So m is mass of the flywheel, k is radius of gyration of the flywheel, I is mass moment of inertia of the flywheel, which is equal to mk square, and n1 and n2 is maximum and minimum speed during cycles in rpm, omega 1 and omega 2 maximum and minimum angular speed during cycle in radian per second, and capital N is mean speed during the cycle in rpm, n1 plus n2 divided by 2. Omega is mean angular speed, omega 1 plus omega 2 divided by 2. Then cs is coefficient of fluctuation of speed, n1 minus n2 divided by n, or omega 1 minus omega 2 divided by omega. So here the mean kinetic energy of the flywheel, that is E, which is equal to half m k square omega square in Newton meter or joules. So that is the kinetic energy of the flywheel. And del E, that is del E, which is equal to maximum kinetic energy minus minimum kinetic energy. So the final derivation we get mk square omega square cs. The cs is fluctuation, that is fluctuation of coefficient of fluctuation, and del E equal to m r square omega square cs. So that is the equation for del E. And this is note, the density of cast iron may be taken as 7260 kg per meter cube. So for cast iron density is 7260 kg per meter cube. For cast steel it may be taken as 7800 kg per meter cube. Then mass of the flywheel m equal to volume into density, that is 2 pi r into a into rho, and a is b into t. So b is width of the rim, t is thickness of the rim. So b by t, which is usually taken as 2. When the flywheel is to be used as a pulley, then the width of the rim should be taken as 20 to 40 mm greater than the width of the belt. So that is the assumptions you have to take during calculation. And the coefficient of fluctuation of energy, that is Ce, which is equal to maximum fluctuation of energy divided by work done per cycle. So work done per cycle, T mean into theta, and T mean, which is equal to P into 60 divided by 2 pi n, which is equal to P by omega. So where omega equal to 2 pi n by 60. So work done per cycle may be obtained by using the following relationship, that is P into 60 divided by n. So small n, which is equal to n by 2 in case of 4-stroke in IC engine. So small n equal to n in case of steam engine and 2-stroke internal combustion engine. Small n equal to number of working strokes per minute. And the next is permissible value of coefficient of fluctuation of speed, cs. So the types of machines, so based on the applications of flywheel, that is types of machine or class of service, so based on the application you can select the coefficient of fluctuation of speed. So for crushing machine 0.200, for electrical machines 0.003, gear wheel transmission 0.020. So likewise you can select, so based on the application you can select the coefficient of fluctuation of speed. At the same time you can select coefficient of fluctuation of energy Ce based on the 4-stroke or single cylinder double acting steam engine, single cylinder single acting 4-stroke gas engine. So likewise you can select based on the application. And the next we move on to the design data book, page number 7.120. So the full page is for flywheel, that is 7.120. So the data are available, and Delhi formula is available, IKS omega square, and W formula will be available, pi d bh nu, and bending stress formula will be available, that is stresses in the rim. So bending stress and stresses in the arm at the hub end. So stress and cast iron, what is sigma b, that is available. Then section of arm A equal to 3 root of 64 zyy divided by pi. So the formulas are available, and Ks, coefficient of fluctuation of speed, omega 1 minus omega 2 divided by omega. So all the formulas will be available. So based on the calculation, you can take the formula and substitute and find out the values. The next page number 7.121. So here we can select the Ks value, that is value of Ks, fluctuation of energy, driven machinery. So based on the application, based on the type of drive, so you can select the values. So this is two page number very much useful for flywheels, that is 7.120 and 7.121. So during the calculation, so we come to know how to select the formulas and how to solve step by step procedure of flywheel. So that we will discuss in the next class. Thank you.